Hello guys. So let's solve this Leetcode medium problem which was asked in Salesforce as well as Citadel interviews. So trust me, after watching this video you'll code out the solution in your own. And I have broken down the problem into small manageable units which makes sense to think of even during an interview setting. So the only condition is that you have to watch the video completely and not leave midway. You'd understand everything. I would go from the brute force approach up until the most optimal, and also I would do dry runs. So everything would be like very clear to all of you guys. And please, this takes a lot of effort, so like and subscribe to my channel. This is the nums array example given to us, k as 2, and here we have to partition this array into subsequences, and the count of that should be minimum such that each subsequence can have like only one unique element. One element can be in only one subsequence, like 1 can only be in one subsequence, 2 can only be in one subsequence, and we have to distribute this in such a way such that minimum number of subsequences should be produced, and in those subsequences our max of subsequence nums minus min of subsequence nums should be less than or equal to k. This is the condition. Here is the example. First thing which I would tell an interviewer is that I can use a brute force approach where I would have two options for each element. Either put that element in the same subsequence or a different subsequence. So I would draw out the dry run of this brute force backtracking solution. So this is our index at 0 position. This is our partition array which would specify which subsequences we are forming. For same addition, here we added the value of the index 0 position 3. For the different addition, also because there is no previous subarray present here, these both come out to be the same 3. Now we would move from the first index, which is 6. Same addition, same subsequence addition, so we would add it in the 3. So 3 6, it becomes 3 6, and in the different one we have 3 here, and we would create an additional subsequence 6. So this way we are creating all the subsequences. Again we are adding it in the same or different. This way we would consider all of the subsequences possible, and afterwards when we reach the base condition, that is when I is equals to n, we would validate every partition subsequence using the condition this, and even if one of the subsequences does not satisfy this condition, we would break out of this loop where we are validating every subsequence and return. But if all the subsequences satisfy that condition, we had taken out a min sub variable and we have kept it to int max at first so that we can compare and decrement it to the minimum possible value which we would return at the end. So time complexity here is 2 raised to power n for the choices, and for validation purposes again n. Space complexity is O of n. So this solution is not feasible. The interviewer would not be satisfied. He would not even ask you to code it. He would tell you to optimize it. So, but even if you do a dry run, the interviewer would get satisfied and like give you 2 marks. Suppose you're not getting the optimal approach in the interview, maybe the interviewer can give you a hint, or maybe he would ask you to code up this solution only. So there would be 2 choices. In that case you have to code it up, but if you did a dry run, the coding up part becomes very easy. And if he gave you a hint, or if you only discovered that only we have to do counting of the subsequences, so we can sort and count subsequences with the condition of max sub minus min sub less than. So whenever our value becomes greater than k, we need a new subsequence, so subsequence count would increase. So all the maximum possible values which can be inside a subsequence would be at the front of the sorted array. So we would always get a minimum count in this case because of sorting. Every element should be only in one subsequence. That condition will also be satisfied because all the sorted ones would be at the starting. So if max of sub minus min is greater than minimum of sub plus k, so we need a new subarray. Count would be incremented by 1. So I'm doing a dry run of this, the same example I'm choosing. Sorting it would give us this 1 2 3 5 6. Now we would iterate over each value. Our k is 2 here. Count I would initialize it as 1 because at least one subarray would be there, even if the element is only a single one. And I would initialize my minimum subarray value with the num0, which is 1. Now I would iterate up from I equals to 1 up to the end, which is I equals to 4. Now I would check the nums I value, which is 2 here. It is less than nums min sub plus k, which is 1 plus 2. So it would be inside the same subarray. So here 1 and 2. For I equals to 2, 3 equals to 3, same subarray again. Because the condition is the max minus min cannot be greater than k. It can be exactly equal to k. For 3, I equals to 3, we are at 5 value, and 1 plus 2, which is a different sub. So we would need a different subarray here. The order of subsequence doesn't matter here because we only need to find out the count. That is why we can sort. If the order was necessary, we would not be able to sort. The backtracking solution would have worked there. So 5 is greater than 1 plus 2. Different subarray needed. So count would be incremented by 1 here. I would update my minimum to now this minimum nums of I, which is 5. Now for I equals to 4, 6 is less than 5 plus 2, 7, so same. So 6 is also added here. Our count is 2 that we would return. Dry running it in an interview would also impress the interviewer. You can even ask for a specific example from the interviewer and dry run that case also, so that it becomes even more clearer. Even he can ask you to dry run on a specific case which he thinks is an edge case. If nums is bounded, can use counting sort. So if my nums values range from 0 to suppose 10 raised to power 5, which is the case in this question. You can ask the interviewer this constraint. You can ask this constraint to an interviewer. He would tell you what is the constraint, and if it is 10 power 9, that is a random, you cannot apply there. Only here, if it is bounded to 10 power 5 or 10 power 6, you can use this method, counting sort. I am dry running that counting sort. Counting sort takes O of n time instead of O of n log n, so it could be optimized one step further. That's it. Otherwise, you can give the greedy solution also in case of the constraint reaching this higher power. So I would initialize my count array with maximum of whatever nums is given to us. Here it's 6 plus 1, so I would initialize it by 7 zeros. This is it, and iterate over the nums given to us. First one was 3, so I incremented its frequency by 1. The index represents the number here, and the value represents the frequency. So I would fill up all of that. Afterwards, I would reconstruct my sorted nums. Index I would initialize with 0. I would range from 0 to count of length minus 1, which is here 7. I equals to 0. Count of 0 is 0 here, so I would just increment I. If I is 1, count of 1 is 1 equals to greater than 0. So I would put that I value in the nums of index. So while if it's greater than 0, I would substitute that index with the I value and increment both the index and the I value and decrement the count. Here it's 1, so we don't need to do that, but if many such ones are present, this can be done so that we would get the sorted nums later. So here we were getting 1, I equals to 2 nothing, 2, 3, 5 and 6. Count of 2 was also 1. See, so I did the same thing. This is created. Now we can again use the same concept of minimum sub as the 0th index value and comparing. The same we used with normal sorting, and that was it. So this was today's problem. Please like and subscribe to my channel so that I get motivated to bring out the solutions for you daily. Thank you and have a nice day.